Hello students, this is the continuation of the next video for the chapter of rational numbers for the 8th class, and this is the part 3. So today we are going to discuss the commutative property, which is one of the very interesting, because here if you interchange the LHS and RHS of any number, like for example if I am taking the example of 0 plus 7, and if I write the same number to the other side, that is 7 plus 0, and this is the example of the whole number in commutative property. So this is nothing but the same thing which I have written in the other side, that is same. This is the LHS and this is the RHS. Okay, so does it if it is there any difference in the answers, like if I plus this one, then answer is 7, if I plus this one, the answer is 7, so it doesn't impact anything. So this is the concept of the commutative property. So we have covered the first one, that is the whole number. Let's see the second one, that is the okay, this is the same whole number. Under that I have the two things, like first one is the addition thing, which I have just done. 0 plus 7 equals to 7 plus 0. Okay, the answer is same both the sides, so there is no impact in the commutative property in addition. So what our result is, yes, the addition in addition it is commutative. So hence this is proved that in the whole number the addition commutative is there, and it is meeting the expectation. The second one is subtraction. So in the subtraction commutative property, so subtraction is not meeting the commutative property in the whole number. Similarly, we have the next topic, that is rational number. This whole number is completed. Let's see the rational number, that is the second one. Rational number. So in this again, the same thing, like A part is like addition. In addition, we also have some example like this, which is already is there in the book, NCERT book. So I have not taken anything different from the NCERT book. This is the concept, and these are the examples from the NCERT book itself. So whenever you are referring, you will get the same result from same example from the book. So minus 2 upon 3 plus 5 upon 7. Okay, we'll see the result, but let's convert this thing to the LHS. This is the RHS and this is the LHS side. So let's see, 5 upon 7 and plus minus 2 upon 3. So again the number is the same, but we have just interchanged this from left to right. Let's see the answer here. We know that if the denominators are different, then we need to make it 1. That is I have to take 21 here as a LCM. We know how to find the LCM, like 3 and 7. So this is the 3, 1, and the 7 is left. So 7, 1, 1. So multiply 3 into 7, that is 21. So here we have the denominator 21. So let's see if I able to do this. This is the 3 into 7, that is minus 14 plus, and this is the 3, 15. So if we sum up, this plus minus is minus, of course, and this is 21. And if I see here, so again it's 21, okay, and this comes like 7 into 3, that is 15, plus minus minus, and here is 16 into 3, 7, 40. Okay, so here we have 1 upon 21. Here I need to change the sign because I have to take the greater one, the sign for the greater one. So both the side is correct. So in this rational numbers addition condition is satisfied in the commutative property. So yes, this is the commutative property. So likewise, we have many other examples in this commutative property. Okay, so you can try, and if you find any difficulty, then you can comment me or you can ask me anywhere. Anyways, okay. So today I want to cover something the other than this topic, like commutative property we have covered, and let's see the third property, that is associativity property. That is associativity. So this is the associativity property. This is the third one. Okay, so let's see how we can see and prove this associative property in the rational number. So first of all, I start with the addition part. So if I come with the first part, that is addition. I have the example for this as well. It's like 7 plus 2 plus 3 equals to, let's reverse it, like plus 2 plus 7. Okay, so here we have result like 10, 12, and here we have result like 12. Okay, so I think this condition is meeting the expectation of the associativity property, and here we have proof, yes. But in the subtraction, let's see if this is associative property or not. So second is in the subtraction. Similarly, we can check the parameters for subtraction as well, and the multiplication. As well in the associative property. Let's come to the next topic, that is associative property in the integer. This is the second one. Integers. So we know that if you do the addition in the integer part, this is associative property, and it will give you the result. Definitely it will give you the result. If I take any number, like let's take any integer like minus 5 plus 3 equals to anything, like and let's see an example like 2, and if I reverse it, minus 5, then it also gives you 2. So the result is same in the plus or the addition condition. Similarly, you can test for the subtraction. So it is not satisfied, because anything which is LHS is, let's suppose, minus, then it will change their sign when it comes to a RHS. So negative will become positive and positive will become negative. This is the vice versa, which we have already seen in the first video. So these are the rules of the LHS and RHS. So this will not satisfy the associative property. Let's see the third one, that is multiplication. Multiplication. So this could also satisfy the associative property. You can take the example and try, and if it is not resolved, then you can ask me in the comment. Okay. Next, division. It's also not fulfill the condition of the associative property because it's a division. So again, this is, and this subtraction is same, treating the same, and this is addition and the multiplication, which is the multiplication is the repetitive addition part. So we will able to understood that, right? So let's see. So the next topic is rational number. Like this is the integer whole number we have covered. So third topic is integer. Rational number. Third topic is rational number. Sorry, my handwriting is not so good, so you can just adjust. Okay. Let's see. The first A1 is addition, in the addition part. Okay. So if I take some example like 2 by 3 plus 3 upon 5 plus minus 5 upon 6. So if I take the if I resolve this equation, then I'll get the answer. Let's resolve it. For example, these are the different in the numbers. These are the different denominators. So we need to first find it out, the common denominator for this, and we know that how to find it out. But if I follow the associative property in this method, I need to write the same equation in the other side, that is RHS side. This is, let's suppose, LHS side. Okay, let's write this same equation to the RHS side. Then the expression of this equation is like this: plus 3 upon 5 and plus minus, so it should be minus 5 upon 6. So this is the expression of the right hand side. So left hand side expression is this. If you solve, if you do the calculations, you will get the answer. I have already found it out in the rough page. This is the answer for that, and the RH is also minus 9 upon 10. So this equation, this rational number in addition is satisfying the associative property. Similarly, you will be able to find it out the addition, subtraction, multiplication, and other integers as well in the associative property. So let's see some more examples, and after this we have already covered the 3 properties in the rational number, which is our very first chapter in the 8th class. And 8th class. So students, you might think that why I have divided the whole chapter in the 3 parts, although we can complete in one go as well, like the other teachers are doing on the online classes. But why? The motive behind it is like not to complete the chapter, but to make you understood, each and every concept of rational number. So once you understand the clear-cut things of the rational number, you will able to resolve the exercises. We have 2 exercises in this book, 1 and 2. So try to solve the problems in the exercise 1 and exercise 2 And if you find any difficulties, just mention in the comment section. So, sir, I'm not able to do this one. So I'll explain how it will be resolved, okay? And which method you need to follow, and which property, according to which property you are able to resolve all these things. So it's very easy to take the example from the exercise and resolve it and prove it. This is the answer for this, that and that. It's very easy. But if you are able to understand the concept thoroughly, you are able to resolve all these exercises by your own. So think how you feel if you do all the exercises by your own. It's really feel good. It's really feel good. Definitely you will enjoy this moment. So my motto is not to complete the exercises and take the examples from the book and complete it. Just try to understand the basic concepts behind it and make you independent to resolve all the exercises of the book by your own. So try these exercises, and if you find any difficulties, I'm here to teach you, or you can write in the comment, this question is not able to resolve. What is the exact method to resolve this particular question in the exercises? So, a part of these properties, we have certain interesting things like the role of 0. The role of 0. Okay. So, what is the impact? What is the role of the 0 in the different scenario, like the whole number, integers, and rational number? So, let's see. With an example, I have like a plus 0 equals to 0 plus a. This comes under the whole number scenario. So the uses of the 0, which is already comes under the whole number, because we already do many things to understand the whole number, integers, and rational numbers. So I'm sure you will able to know the concepts here, like natural number, whole number. Okay, so I need not to go again in that topics to waste the time. So I'm sure you will definitely have no doubt, and if you have any doubt, you can comment me and ask. Okay, similarly, if I take the another example, that is example number 2, that is b plus 0 plus, or we can say that equals to 0 plus b equals to b. Anyhow, it's b. So this is the example of integer. Okay. So see, the role of 0 is very important in any aspects, and we already know we are the first who has given the 0. India is the first who has given the 0 to the world. So it's very important, and I really like this topic, the role of 0 in our chapter, and a very beginning and very first chapter, that is the rational number in the 8th class. So we should be proud for this. Okay, and let's see this third example. C plus 0 equals to 0 plus c is equal to c. So this is again a rational number. We can say that rational number. Okay, you can write this expression as this as well. Okay, 0 plus c. So definitely you will get the something which is resolved by there 0, and here is 0 plus c. So these are the importance of the 0 in the chapter, which is given in the book as well. You can refer the NCERT book. This is the best book in the world, I can say that, and to understand each and every concept, starting from the beginning to the end, and the each and every point of each and every highlights of the uses of numbers, uses of whole number, integers, rational numbers, what are the natural numbers, what are the various other techniques and the properties. Everything is mentioned in that NCERT book. So let's see the another example, another topic, that is the roll of 1. Again, here is also is roll of 1 is there. So simply here the same answers, like for example 5 multiply 1 is equal to 1 multiply 5. So here is 1. Anything is multiplying with the number 1, the answer is same. Okay. So these are the basic things which we already know maybe, but this is the topic which is given in the chapter, so I just make you understood. Okay, let's move to the next topic, that is reciprocal. So this is the reciprocal. As the we know that the meaning of reciprocal is like reverse of the any rational numbers. For example, if I take one number, that is 8 upon 21, if I do the reciprocal of this, if I do the reciprocal of this 8 by 21, it is 21 upon 8. Okay, so these are the examples. Let's take another example which is also from the book as well. So 7 minus 5, if I do the reciprocal, so it is minus 5 upon 7. So these are the concept of reciprocal. Okay, let's see the another topic for the day. I have done a lot of homework with the textbook and prepared my own notes for you. So it's easy for to teach and easy to understand, and headlines for that. Okay, so let's come to the next topic, that is rational number on the number lines. So it's very interesting and very important thing we are going to teach here and going to learn here, like rational number on the number lines. Rational numbers on number line. Okay, this is really important, very important, I can say that, because in the higher classes as well we are able to see all these number presentation in a various way, not only the rational numbers or the numbers, but many integers, you can say that, simply the whole numbers and the natural numbers as well. So let's see how we present the natural numbers here. So first topic is natural number. Natural number, how to represent it. So try to understand with the open mind, don't take any burden on your mind, and see, like here, natural number, we already know that starting from 1, 2, 3 and so on. We already learned all these things. So simply on the number line, you have to start from 1. 1, 2, 3, 4 and so on. It's in the increasing order. Starting from here 1 and it's go beyond infinity. Okay, so this is in case of natural number. Similarly, in the case of the whole number, the number is started from where the whole number is started from. So it's started from 0. So 0, 1, 2, 3, 4 and so on. So the point is here to remember is starting from the left hand side and moving to the right hand side, infinity. Okay, so similarly we can also present the next topic, that is next point, that is third one, is in integer. If I represent the integer on the number line, so how will I represent it? First of all, it's moving infinity to the both the sides. Okay, and it's starting from 0, isn't it? No, it's not starting from 0. This is the midpoint. This is the midpoint. We can move from right hand side as well, so on, and we can also move to the left hand side by indicating -1, -2, -3, and so on. Okay, so remember this is the midpoint where it divides, or we can say that where it's the midpoint or the breaking even points. We can also write the number lines like this. This is the 0, and we can move 1, 2, 3, 4, and here -1, -2, -3, -4, so on. So it's also moving to the north to south and east to west as well. So this is not a direction which I am going to teach here, but just to know the directions or the way we can remember it. Okay, that's all. So let's see the fourth point, how to represent the rational number. The fourth point is rational number. Rational number. So again, the rational number is always in the upon form, right? We know that -1/2, or 3, 1/3, and maybe 0, maybe, or not this, then maybe something else like -1/3 as well. Okay, so let's represent this on the number line. How will we represent this? This is 0, 1, 2, 3. Okay, this is 1, -1, -2, -3. But how will you represent this? So like for example, -1/2. So here we have the complete 1 from 0 to -1, but it's -1/2. So it is come over here -1/2. Okay. So similarly, if I represent this, okay, so this is not the negative, it's a positive one. So I can simply, this is not 1 complete, so I can just take the 1/3 over here. Okay. So likewise, we can represent many things like 2 by -2 by something, or you can take your own examples as well and try these number lines. If you able to do, then you are well, and if you're not able to do, please mention in the comments so that I can help you how to locate that number in the number lines in the rational number section. Okay. Okay, so this one is completed now. I have the only one topic which is very important, and with the point of view of exam as well, like how many rational numbers in between the two rational numbers. This is very important. So questions will come, this type of questions will definitely come in the exam. One of the question or two of the questions based on this concept, like how many rational numbers in between two rational numbers, So let's take an example, 4 by 10. Sorry, I have to write the question here. The question is 3 by 10 and 7 by 10. Let's take the denominator same so that we can able to find in a correct way. If it is different, then you have to find the same denominator by doing the LCM method and just find the denominator same. This is the mandatory. Okay, so in between, how many I need to find it out the two rational numbers. So it's very easy, so that I can do by my own, like 4 by 10 or 5 by 10 and 6 by 10. Okay, so these are the rational numbers in between. So it's asking for the 2, I have found the 3. You can write any 2, like this or this, both. So only 2 is required here, so just remember this one. Okay, so let's see the another example, which is very important with the point of view of exam. And find the rational number, write the 3 rational numbers in between -2 and 0. So this is very important, and we know that this is really maybe it's asked in the question, asked in the exam as well. So let's see, -2 can be written as, -2 can be written as let's suppose like this. Okay, so why we are writing like this? Because just to make sure, or make the easy way to find it out, the 3 rational numbers in between these 2 things. So let's see. So starting from the and as 0. So 0 is like 0 by 10. Okay, so it's very simple. For example, in the number line, I have started from 0. Okay, let's consider this is the 0 point. Okay, and here I need to go to up to 10, minus 20 upon 10. So what do you think? Like how many? It's asking for only 3 rational numbers is asking. So you can give n number of, or you can give any number of, like 16 upon 10. Okay, 17 upon 10, 18 upon, minus 18 upon 10. Okay, so likewise you can give n number of the rational number examples in between the -2 and the 0. Okay, you can take another example. You can try your own example. If you're not able to find it out like this, you can comment me, or you can ask me in the comment section, so that I can cover it in the next video. Okay, so these are the very important tricks, very important topics for the rational numbers. So that's all for today, and if you have any question, please write in the chat box, and do like and subscribe this channel as well, to promote my effort and to encourage me for the better videos and the better topics. I have tried to cover almost all the topics from the NCERT book, and if anything left, you can also mention the comment as a suggestion, so that I can cover it into the next video and the next chapter as well. Okay, thank you so much. Keep safe yourself. Thank you.